You're welcome.
Okay, we're going to continue talking about transformations and reflections. Today is specifically reflections. So last week we talked about transformations, right, which was just moving left and right. So our original image was moving left and right. When we say reflection, what does that make you think of?
Mirror.
Right? So like a mirror image, okay? So everything we're doing today is going to be essentially like a mirror image, okay? All right. So a reflection is a type of transformation. A transformation that uses a line like a mirror to reflect a figure. This line is called a line of reflection. Is that better? Okay. So, as you can see, like on our first example, we have, if you have an original here, our line of reflection on this, okay, would be like you could call it the y-axis, or it could be a line x equal to 4, anything like that, okay? So notice if our line of reflection is a vertical line, what type of reflection do we see? Horizontal, right? Okay. If our line of reflection is a horizontal line, then we see a vertical reflection, flips up and down. Okay? All right, so here's some rules for us. We'll go through some examples, hopefully make it easy for you. A reflection in the y-axis, a reflection in the x-axis, all that happens is our y changes signs. So specifically, if we're talking about ordered pairs and it's saying we're reflecting across the x-axis, all we're going to go through and do is change the y value to its opposite. So now we would call this x and negative y. Okay, so knowing that my y value is going to change signs, who can tell me what my ordered pair for a prime would be?
-6 and then
-6, -5. X stays the same, y changes to its opposite. Okay, somebody else tell me b prime. -6, -1. And what about c prime? -1, -1.
How do you hear that? I really heard that.
Who was that? Oh. Just listening, you know. Okay. All right. Simple enough, yes? If we reflect across the x, we change the sign of the y value. Now, the other thing that is possible to do, right? Well, I'll graph these points and I'll show you. So, -6, -5 would be here. That would be a prime. -6, -1 is here for b prime. And then -1, -1, c prime. Okay, now, the other thing I'm going to tell you, right, just for like graphing purposes, if we're reflecting across the x-axis, how far away is point C from the x-axis? 1 unit. And then how far away is C prime from the x-axis?
1 unit.
So you could just count to the x-axis. It's 1 unit away. Count 1 further, put your point. Same thing for B. It was 1 unit from the x-axis. I count on the other side. Now A is a little different, right? 1, 2, 3, 4, 5 units away. So then I count 1, 2, 3, 4, 5 units away. Bless you. Okay? So that is another way to do it. You can count to the axis, count on the other side. All right? Simple enough? Okay, now let's talk about reflection in the y-axis. So on x-axis, the y value changed signs. What do you think is going to happen with the y-axis? Yes.
More so smart.
Some days.
No, it's That's every day.
Why are you laughing, Turner? Okay, so what would be my new rule for my ordered pair then?
6, 5.
Well, first tell me the rule.
Negative x, y.
Yes, negative xy. Okay, and then Turner, a prime would be 6, 5. Okay,
6, 1.
6, 1. And 1, 1 for C, right? So just going through, changing the sign of our x value. Okay, and then we can plot those points on here. So A is at 6, 5, A prime. B prime is at 6, 1. C prime is at 1, 1. Okay,
Austin just sent a talk my paper. My cute little note.
I'll take care of that. No worries.
Make him do.
All right. Yeah,
I just,
all of yours.
I just wrote him a cute one. I'm giving you a 0.
What a punishment. Okay, let's move to the back page. Back page does get a little more involved. Not a ton, but. Okay. All right, we're going to look at reflection of the line y is equal to x. So, the line y equals x, right? If I put it in slope-intercept form, would be y equals 1x plus 0. Agree?
Yeah.
Okay, so what that line looks like, I'm going to go ahead and put that on my graph. If I start at 0 and go up 1, right 1, okay, it's essentially just straight through here. Bless you. We're going to pretend that that's perfect, right? So we're trying to reflect this image, a mirror image over on this side, okay? So our rule for y is equal to x is going to be to swap x and y. So if all I'm doing is swapping x and y, what would my new rule be? I'm not asking you to change them yet, but my new rule would be y then x.
So,
Now, we understand, right? That doesn't mean we're just graphing y first. It's just y becomes the x value, x becomes the y value. Yes? Okay, so, Austin, what would be a prime?
negative 5, 0.
Okay. Aixa, what about b prime?
Negative 1, 1.
Okay. Macy, what about c prime?
Negative 5, 5.
Good. Okay, so we just swap those values, and then I go and I plot these new ordered pairs. Okay, so I'm going to do that in negative 5, 0 would be here for a prime. Negative 1, positive 1 for b prime. And negative 5, positive 5 for c prime.
Booyah.
Okay. All right. Last one we're going to talk about here on this type of reflection is the line y equals negative x, which, remember, if we're in slope-intercept form, looks like what?
Y equals negative 1x plus 0.
Good.
Good boy.
So essentially, it's really similar to the same line we just drew over here, except it's going the opposite direction, right? Let me turn this for just a second. So it's going to look like this. Okay. Anybody have an idea what that's going to look like? Like what we would do here?
Like the roll?
Yeah.
Negative y x.
Or would it be y negative x?
You're close to negative yx. Not just negative y, but also,
Oh, they're both negative.
yes.
Oh,
So we
negative y.
swap
Okay.
x and y and change signs. So negative y, negative x.
So how do we know when to swap the signs like that?
When it's negative, when y equals negative x, right? So on our original one, Rowdy, it was just y equals positive x.
Yeah.
So we just swap the signs, or swap the ordered pairs. When it's y equals a negative x, that tells you to change your signs also.
So they're both going to be negative.
Yes. Well, in this case, yes.
Okay.
Right? Because all of our ordered pairs start as positive, so in this case, everything changes to a negative.
So if it
Now,
if A was like 2, negative 3, it would be negative 2, 3. Would you change both signs?
yes, but then you also have to switch those numbers.
Oh, okay.
Okay? What's up, Serenity?
Where's your point?
What point?
Students, if you have Coach Bull for RTI, you need to report to his class during that time today. Thank you.
Okay, sorry. Ask me one more time.
Where's your point? Like, negative 1 and 0.
Negative 1 and 0. I don't know where you're getting negative 1 and 0.
Okay, never mind.
Oh,
Like, just where's your point on your?
well, I just didn't put it there. Like, I just drew in the line like this. But, I mean, the point's right here all the way down.
Okay. So it's just a 0.
Is that what you were asking?
Yeah.
Yeah.
Okay.
Sorry. Yeah, I just didn't put those because I know what the line looks like. But yes, you could start at 0 and then down 1, right 1, down 1, right 1, all the way down. Okay. Which, in all reality, you guys, this part doesn't really matter to me. You don't have to draw that in every time. I'm just showing you what that's, because sometimes it's easier. Like, when I have this picture of this, it's easy now to see the reflection across. Agree? So that's the only reason I'm drawing that in for you. Okay. All right. Let's talk about A prime. Joss, can you tell me what A prime would be if we swap them and change the signs?
Negative 3, negative 2.
Good. Negative 3, negative 2. Okay. Kyler, what about B prime?
Negative 5, negative 6.
Good. And then Rowdy, C prime.
Negative 5, negative 1.
Perfect. Okay. So we plot those points. Negative 3, negative 2 is A prime. Negative 5, negative 6. B prime. And negative 5, negative 1. C prime. Okay. Because remember, it's kind of like when you guys were kids, did you ever like take a piece of paper and put paint inside of it and fold it together?
Yeah.
Anybody? Right? And when you open it up, it's like the same on both sides. Yes? So I don't know why you're looking at me like that, Austin. It's no fun if you didn't do it. You should try it. It's a good time. So here's the deal. Sometimes when we look at this, it doesn't necessarily look like a mirror image, correct? But what you have to think of is if I folded this, like if the black triangle was in ink and the, well, really if it was just the black triangle, if that was ink, right? And I folded this along this dotted line, that is what's going to give me the green triangle over here. Okay? So it's our mirror image. Bad analogy for you, Burkeen. My apologies.
It's okay.
Okay. All right.
I know what you meant.
Here we go. Last two. Vertical line and horizontal line. How do I know that x equals 2 or negative 2 is a vertical line? What little thing do we use to help us remember that?
X.
The Hoy and.
Yeah, right.
Oh, yeah.
Right? Hoivux tells us it's a vertical line at negative 2. So what we're going to do is we're going to put in the vertical line at negative 2. And then we're going to use that little trick I told you earlier about just moving your points. Move it to the vertical line, move it past. Now, here's where it's just a little bit tricky, right? Some points are on the left side, some points are on the right side. Okay? So let's start with L. I would count 1 to the right and then keep going how many? 1 on the other side. Put my new point. Okay?
I'm failing this part.
No, you're not. Just listen. Listen and watch. Okay? Look at the board. If I'm moving L and I want L prime, L is 1 unit away from the line I'm reflecting across, correct? So then I go 1 unit further on the other side. Now I have L prime. Okay? Then I'm going to do K. How far away is K from my line I'm reflecting across? 1, 2, 3. So I move 1, 2, 3, and I put K prime. How far away is J? 1, 2, 3. I move 1, 2, 3. J prime. Now, anyone have an idea how I would move M? I go the opposite way, right? Because I have to go to the line of reflection. So that would be 2 units this way. I go 2 more, put M prime. Then I just connect my dots.
I like playing connect the dot. It's fun.
Doesn't have to be perfect. Mine are kind of messing up a little bit, but
I mean, if you can. On the heck of it, all of that.
one of these days I'm going to bring some and I'll show you. Okay. All right, last one. It does.
Okay.
I'm going to bring it one
So
day.
do we not have to put those into the y-intercept form?
Into what, Rowdy?
Y-intercept form?
Put what?
Oh, it's x equals.
Right, because it's when it's just a vertical line or horizontal line, we kind of get the easy way out. Okay. All right. So easy way out, if I have a line y equals 1, is what type of line? Right? Horizontal line at 1. So I would just draw that in, and I'm going to do the same thing. I'm going to reflect all of my points, right? So J, 1 unit away, I go 1 unit on the other side, and I can go J prime. K, 1, 2, 3 units away, 1, 2, 3 on the other side. Same thing with M. M is 3 units. 3 units down, M prime. And then L is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay.
Okay.
Feel all right about it? In all honesty, you guys, I think the biggest, I think the last two we're capable of because we're just counting. I mean, all of them we are capable of. The toughest ones to remember, I think, are y equals x and y equals negative x.